Alright, now before proceeding, I want to set up a little bit better my physics settings in order to have a more realistic physics simulation basically. So starting from the weight of the car, so let's select the rigid body of the car, which is this mesh here. If you go in the physics properties, you can see the mass is 7 kilograms, which is not very realistic. So let's go in the add-on. We can control the weight of the parts of this car from the add-on. I think it's under here, is under tuning, is under physics, there we go. Weight, just ensure that you are under select all so that we are working on the weight of the entire car. So when I change the weight from here, you can see that we are automatically changing the mass in the physics settings of this rigid body because these two values are connected. This is just a multiplier. So I want to try to reach something like 1000 kilograms. Unfortunately, the maximum allowed from the add-on is 100. So I think I'm gonna manually put a mass of 1000 kilograms from here instead so that I can bypass the add-on. And let's test it under controls. I'm gonna press start, hide the extras, and let's restart the game mode. Alright, there we go. So this is a very heavy car. So the controls of the add-on are here. If you click on show controls, spacebar, brake. But if you have a very heavy car like this, it's never gonna stop. So what I suggest to you is, yes, use a very high mass like this, but when you want to brake, instead of using spacebar, use the backward driving, which is the button S. This is gonna act like a brake and works really good. Look at this. You just have to get a little bit of confidence with this, like every game, by the way. You just have to press brake and then leave it in the right moment so that you avoid extra driving backward like this. Alright, now I also want the floor to affect the deformation of the car. I'm gonna be back to the settings of RBC, but for now let's just edit the floor a little bit. So I can't select the floor. By the way, I just restarted Blender, and as I said before, Blender has reset the substeps to 8, which I don't want, so I'm gonna reset this to 4. The other two values, like the speed and the solver iteration, they are okay. Now I want to select the floor, so I'm gonna, with the mouse here, control space to maximize this panel. Let's find the floor, which is this mesh, RBC ground, and in the right here there is this icon for the selectability. Activate this icon. Let's go back from this window, and finally I can select hopefully the floor. Yes, I'm gonna enter edit mode. In face mode, I'm gonna press A to select all the faces, and then I'm gonna extrude this face down by pressing E, like that. I'm gonna have a very huge thickness to the ground. This is very convenient because, especially when you have low substeps like this is gonna help Blender to avoid the intersection during physics simulation, especially with particles when it will be the moment to break the glasses. So after that, I'm gonna select all the faces by pressing A and then press Shift N to recalculate correctly all the normals, and then we can finally exit from edit mode. Now at this point we have created an object with thickness, so we have to reset correctly the origin that at the moment is here. So object set origin to center of mass volume. Now I want to activate the dynamic paint for the floor, so under physics properties, this is already a rigid body, but I want to also activate dynamic paint. This is going to be another brush like the sphere, so I'm going to set this on brush, add brush. Let's click on this button, and I'm going to choose as a source mesh volume plus proximity, and as the sphere I want a very low distance like 0.01, so that the car is gonna deform only when it's gonna really touch the floor. Now let's stay in side view and see what happens. Let's save the project maybe, and if I press just the spacebar, so it's working, but the car is immediately deforming whenever I just started the animation for some reason. The reason is simple, is very simple. If you start the animation and stop it in the right moment, you will see this. The car is literally bouncing a lot because, of course, we have increased the mass. 1000 kilograms is a lot of weight. At this point, this is the part in which we started to tweak a little bit all the physics settings for the car from the add-on. But again, remember that all the settings are going to be subject to adjustment during the entire course, because we are going to add additional rigid bodies, additional weights, so we're going to always change the general physics setup. But for now, let's just see what we can do. The suspension are not enough strong, so we can increase the strength of the suspensions by going in the add-on and under tuning. Yeah, there we go, suspensions and the spring stiffness. So I'm going to increase the spring stiffness to maybe 2000. Let's exaggerate a little bit. Yeah, these are very strong suspensions. So now, if you want these suspensions to bounce a little bit less, you can increase the damping of the spring, but I actually like a lot of bounces and give a more dynamic simulation. So I'm just gonna leave it like this. Eventually, you can even decrease the limits of the suspension. Let's try 0.8 and there you go. Okay, try again to drive the car like this. Yeah, it's going fine. Maybe you want to have a faster car, and so in the Aeron is under control actually here. Drive speed, but you have to be very careful. I'm gonna just increase it a little bit to 30. Let's start again. Yeah, if you exaggerate with the drive speed, the car is probably gonna roll down on the floor. So by consequence, you're gonna have to decrease the friction of the tires. Yeah, you know, all these settings are connected to each other. There's not just one button that you activate and it's gonna work for you. It's all a combination. This is pretty fine, by the way. One of my favorite settings on this Aeron is the capability of using slow motion. If at some point you press shift, look at this. I'm gonna try to make this jump, and in the right moment I'm gonna press shift. There we go. We are activating the slow motion. This is very cool. And you can even decide how much is gonna be slow the slow motion from here. World speed. I think the voice is wrong because this is not supposed to be the world speed. This is the slow motion amount. So I'm gonna decrease this to 0.1 to have a very high speed camera slow motion. I'm gonna press shift right now, and this is now very slow. This is amazing. By the way, there's another thing that I want to do. If you go in wireframe and select the rigid body, so a few of my favorite settings for any rigid bodies in Blender. Let's select the rigid body of the car, so the body RB. Let's go in the physics properties panel here, all the way down under dynamics. I am gonna decrease the damping translation and damping rotation. So both of these two values are gonna be set on 0.01, which is very low. And this is gonna give me more dynamic physics simulations, because basically the damping is limiting the amount of rotation and movement that every rigid body is going to have. If you decrease the damping, you're going to have more rotation, more movement, a more dynamic scene in general. Let's remember to do this for all the rigid bodies that we're going to create later. Alright, I want to suggest you to use the quick favorites. Look at this. If I press Q, I have these quick favorites in my custom menu, which is also including the start button. This is very comfortable, and you can do the same. Basically, I'm gonna remake it for you. So you go in the start button and right click and choose add to quick favorites. This means that from now on, whatever is your mouse, you just press Q and choose start. This is going to speed up your workflow a lot. This way, I don't have to go here every time I needed to start the simulation. Cool. Alright, next part. We're gonna think now about the doors and the hood, basically all the parts that are gonna rotate a little bit. So for this part, I'm gonna turn off the random visualization. I'm gonna stay in object visualization. I want you to download another free add-on. It's called Visual Limits. I leave you the link in the description. Just takes a few seconds. So when you open this page, just go under this button code and choose download zip. Once you get the zip file, the particular thing about this is that we have to extract it differently from RBC Aeron instead. So just find your master file and extract it, easy like that. And then for the installation in Blender, just go to Edit, Preferences, Add-ons, and just click on Install. And usually you just need to load the zip file, but in this case, for this Aeron, we need to find inside the extracted folder, you have to find this file, the visual limits.py Python. Install add-on. After that, you also have to use the search bar for finding this Aeron and just ensure that it is activated in this checkbox here. And finally click in Save Preferences. Basically, this Aeron is very useful for having a visual representation of how much the doors are gonna rotate when they open or stuff like that. Very helpful. Let's reveal all the parts collection, and I'm gonna start with the hood, which is this part here. Let's isolate it. So in the outliner here, I'm gonna create a new collection now by clicking on this button. And I am gonna rename this collection Rigid Bodies, because inside this collection we're gonna put a bunch of rigid bodies from now on. But this collection, I want this collection to stay outside, so let's put it inside the main scene collection. Alright, it should be, if you scroll down, it should be here now. Now I want also another collection, so I'm gonna click again on this button, and you can see this new collection. Let's actually put it outside here. There we go. I'm gonna rename this collection Main Constraints. Please just ensure twice that these two collections are not inside other collection. So eventually just drag these two collections into the scene collection, which is the main collection basically. All right, now with the rigid bodies collection selected, I'm gonna go here and just create a cube. There we go. Where is my cube? Oh, it's outside, of course. Whenever you want to create something in a specific place, just press shift and right click so that you can decide where to create a new object. And let's stay in wireframe mode. So this is gonna be the rigid body of the hood. We just need to make a cube, easy like that. Don't go crazy in modeling. So the rigid body for the hood should be smaller compared to the original hood, and let's find it in here under rigid body. This cube, I want to rename it. I'm gonna call it front hood RB, which stands for rigid body. Still that we are here, let's turn off the visibility for the render, which is this icon in the right part, for the entire collection, so that every rigid body that we're gonna create is not gonna be visible when we export. There is another thing that I want to do with this rigid body. Under object properties and viewport display as, I'm gonna choose wire, and also I'm gonna activate the in front option so that this is gonna be visible from every angle, even if this is inside the hood. And let's adjust the shape a little bit. It's gonna be almost flat. So I'm not gonna put the rigid body here, but a little bit lower like this. Even if it goes a little bit outside, it's okay, it's okay. If you want, you can model a little bit better the shape in order to be a little bit curved. Yeah, let's do it. So I'm gonna press tab to enter edit mode and then control R to make an edge loop. And if you scroll up or down your mouse wheel, you can even decide how many loops you want. In this case, I just want one loop like this, and then move it wherever you want. Like here, we can move these edges. Oh, there is the proportional editing. Let's turn off the proportional editing from this button, and let's move this. Actually, let's stay in vertices mode with transparency activated. I'm gonna move instead these vertices down like this. So this is the shape that I got finally. I'm gonna put it a little bit up like this. Let's see from the top. And eventually, if you want to get fancy, you can even model a more precise shape, like enter in edit mode, control R, a double edge loop like this, and then ask. In vertices mode, I'm going to select these vertices and move them a little bit more forward. Let's just ensure that we are creating a nice shape like this. All right, a very simple shape. By the way, when it comes to rigid bodies, you simply need to create cubes, nothing more than that. I want to have a lot of space for the deformation in the front part here, basically. So we can even push it a little bit more like this. All right, maybe don't exaggerate with the space. Okay, this is more than enough for what we need. I just finished creating a rigid body, and so the first thing to do is Control A, apply scale, Control A, apply rotation. Then I'm gonna go to object, set origin to center of mass volume, which is this one, and then in edit mode I'm gonna select all faces and then press Shift N to fix all the normals, and we can finally exit from edit mode. And now it's time to make the deform mesh. For the deform mesh, I am gonna make it in a different way compared to how we made the deform mesh for the car. So for the car, we made basically a convex shape that was surrounding the entire car, and then for the car we gave a mesh deform modifier. Instead, in this case, the mesh deform modifier is not gonna work because when the displacement is going to happen, this top part is going to displace like going down like this, and instead the part in the bottom is going to go up like this, generating self-intersections. And for this reason, I'm going to use a little bit a different system. So as a deform mesh, we are going to use a flat plane, and instead of using the mesh deform modifier, we are going to use instead the surface deform modifier. I'm going to explain to you more in detail now. So let's stay in solid view, maybe with transparency activated, something around here in the collection of the deform meshes. Just ensure to select it. Let's create a mesh plane this time. So just a flat mesh plane like this. I'm gonna rename this mesh deform front hood. So to summarize, the rigid body should be smaller compared to the original hood. Instead, the deform mesh should be actually a little bit bigger. So it should cover entirely the front hood, the object that we are trying to deform. Just ensure that is everything inside like this. By the way, this is flat. From the side view, I don't really see it, so we can stay in wireframe mode. I can try to cover the majority of the area of this hood like this. And we can even edit a little bit the shape in order to make it a little bit this curve a little bit better. So edit mode, Control R, and just add just one edge loop like this and move it a little bit down like this and move them a little bit up like this, you know, until you make the curve more or less like it is in the original object. Then a particular thing about the deform mesh is that I want this to be a little bit almost outside like this. Not completely outside, but almost outside the original hood. So the rigid body is way much lower compared to the original hood. Instead, the deform mesh is almost outside, but it should intersect actually a little bit. So let's see the shape that we got. Yeah, this is more than enough. We can edit the shape a little bit. So edit mode, Control R this time in this direction, and we can push these faces a little bit up, G and Z, so we can represent a little bit better the actual shape, and then move it down like this. Let's see what we get in solid view without transparency. Maybe we can stay in a random visualization now. Yeah, it should be something like this. You can see that I am intersecting the hood, but it's potentially staying more outside than inside. All right, like so. Let's see in transparency activate. Alright, now we can first of all Control A apply scale and Control A apply rotation. And now we can add a little bit more geometry so that we can let a more high resolution deformation. So let's select all the faces and right click and subdivide. Right click and subdivide again. Let's check the amount of geometry. 117. We can push it more. Right click and subdivide. 400, it's literally too much. I'm gonna go back. So from here, I'm gonna try to make the subdivision manually, basically. So Control R and something like this. Control R here, something like this. All right, after a few edge loops controlled manually, I was able to reach an amount of 180 vertices, which is super fine. By the way, if you have a powerful computer, you can even push the resolution of this mesh a little bit higher. It's up to you. By the way, I don't want to push too much the geometry because I am also recording this tutorial, so my computer is already a little bit overloaded. I don't want to exaggerate losing the real-time response. Nice. Let's see what we get. All right, now I want to do one thing. We're gonna tweak very often these two options under Object Properties, Viewport Display in front and Display As. And so I'm gonna put a little window here. Let's make some space with the mouse here. When it becomes a double arrow, right click, vertical split, and let's make a little, very little space here. We have a new window here that we can use for a specific purpose. So from this top left icon, I'm going to change this little window to properties. So here you can see this voice, and finally we can scroll up or down the mouse here until you find this orange icon, and all the way down here under viewport display. All right, I'm going to leave these two options always visible here so that I can use them whenever I need. For example, now I'm gonna activate in front and display as wire. And now here we can finally change this window to whatever we need so that we don't need to go back there every time. Now, before everything, let's select the original hood and I'm gonna go to modifier, and this time I'm gonna choose surface deform, this modifier here that is different from this one that we used before, because this is gonna deform objects inside another mesh. Instead, the surface deform is useful when we have a flat surface, like in this case. So I'm gonna use this pick tool to choose my target. That is gonna be my deformed front hood. There we go, and we can finally bind it. And now this mesh is connected. We can finally select the deform mesh. So first of all, I'm gonna create the dynamic paint in the physics properties, activate the dynamic paint. This is gonna be a canvas, add canvas. As a surface type, I'm gonna choose weight. This voice here. We can use also the anti-aliasing for a smoother dynamic paint. All the way down here, I'm gonna click on this plus button for creating the vertex group. Then I'm gonna go in the modifiers tab, and I am gonna give modifier displace, and this time as a texture, I'm not gonna create a new texture. I'm gonna simply use the texture that you can find here. Is the texture that we generated before. So I'm gonna use this the same texture for all the deformable parts, so that we don't have to overload our computer with many textures. At this point, this mesh is kind of disturbing, so I'm gonna simply display as, I'm gonna choose bounds, so that we can finally see our actual hood. And now let's go on tweaking some options. For the displacement, I'm gonna decrease it a little bit, like 0.5. Watching from the side, let's see the mid level. I'm gonna push the mid level down, like this, more or less. All right. Let's see from the front. Yeah, this is nice. So there's one thing to say at this point. This is our rigid body. our car, of course, is gonna make some car accident with some walls colliding like this. So I need this geometry, this extra geometry of the hood, to be pushed a little bit inside in order to have a realistic simulation. So for doing this is very easy. We just need to add a secondary displacement to the deform mesh. So the first displacement is responsible for the deformation that happens in this direction, like this, only vertically. Instead, I'm going to create a new displacement. I am working in the deform mesh, pay attention. And this second displacement is going to be responsible for the deformation that is going to push the geometry inside like this. The first displacement, just to have clear ideas, I'm going to rename it displace vertical deformation. And instead, the second is going to be front deformation, just to have clear ideas about what is going on. As a texture, I'm going to, as always, use my beloved texture again. And this time, the particular thing is that in this option, direction, I'm going to choose the Y direction. And look at what happens is that the deformation of this secondary displacement is happening, if you try to tweak it, is going exactly in the direction that we want, which is the horizontal direction. So just don't exaggerate with this, and instead what I want to do is to play with the mid-level. Just play with the mid-level of the secondary displacement until you get it in the right direction that we want, which is this, until it goes a little bit inside the rigid body limit that is here. So I want to push the geometry like this. Also, this part is gonna probably go inside the car, but don't worry, because this part is probably never gonna deform. This is instead the part that potentially is gonna collide with walls and the road and stuff. And so this is just the only part that is gonna go inside. And now let's tweak a little bit all the displacement until we like it. For example, the strength and the strength of this one maybe. Yeah, this is a nice deformation. It's up to you to play with it a little bit more until you like it. Yeah, this is a nice starting point. Of course, with more geometry, the deformation is gonna look a lot better. And now let's connect the dynamic paint into this displacement. So in the first displacement, vertex group, let's choose our dynamic paint group. And also do the same for the second displacement. Vertex group, let's click here and choose DP weight. There we go. We can finally collapse these modifiers so that we can create a little bit of order and just ensure that the dynamic paint comes first and then all the other displacement. All right, later we're going to test it. For now, let's just finish this by creating a constraint that is going to connect the hood to the car. So in the main constraints collection, let's select it. More or less here, I'm going to press Shift A and creating an empty. As a type of empty, I'm going to choose a single arrow. And look at this, we have a new constraint. We don't need to rename the constraint very much. I'm just gonna put this constraint in the right place, which is something around here. It's not necessary to put it in the perfect center. So this constraint will determine the rotation of the hood like this. Let's put it a little bit before, like here, so that we can kind of avoid to create too much empty space between the car and the hood. So more or less here, eventually later we can adjust it. Now with this constraint selected, let's ensure that it is inside the right collection. Yes, I'm gonna go in the physics properties, and by the way, first of all, we can choose in front so that all the constraints are gonna be visible from every point of view, because I don't want to lose any part inside the car. So physics properties, activate rigid body constraints. Let's expand this space a little bit. So as a type of constraint, I'm going to choose generic. First thing to do, I'm going to choose this to be breakable. Why not? But I want this to be very strong, so I'm going to choose a threshold of maybe 1000. So it's going to be very hard that this hood is going to detach completely from the car. Then for the limits, at the first impression, all these options are a little bit confusing, but this is actually very easy to understand. So we have some angular limit. I want to limit the angular motion in all directions. And you can see that visual limits is helping us to understand what exactly are these angular limits. I also want to limit the linear motion of this rigid body. So I'm going to activate all of this. I'm going to put all of this on 0. And look at this. Now this rigid body is never going to move anywhere. It's just going to rotate and stay attached to the car. I'm going to also put all the rotation limits to 0. I want to start from 0 and just use the only direction that I need. Yeah, you can see if you try to tweak some angles, you can understand which one is the right angle that we need. So is the X angle. One thing to understand about the generic constraint or the generic spring constraint. For every direction, you can see X lower, upper, Y lower, Y upper. upper, Z lower, Z upper. For every of these three directions, the lower value should be negative, and instead the upper value should be positive. So the same is for this one. This should be negative, this should be positive, this should be negative, this should be positive. So in this case, I wanted to tweak the X angle. So let's try something like this maybe. One particular thing about visual limits is that, yeah, it helps to understand the range of motion, but it's not orientated correctly most of the times. For example, in this case, you would expect to see that the angle should be this one. Instead, I already know that it's not going to be like this. So just try to tweak these angles until you find that it's working correctly for you. We're going to need to say in the constraint which two rigid bodies we want to connect. So scroll down under objects. The first object, we can try to find manually the vehicle. There we go. Vehicle body, rigid body. As a second object, instead, we can use the pick tool and try to pick the rigid body of the hood. Well, it's down here. I'm going to try again. And there we go. Front hood, rigid body. Check it twice that this must be two rigid bodies. And actually, still that we are here, we need to make this object a rigid body. So physics properties, rigid body, mass, I'm going to choose 15 maybe. As always, down here, damping translation and damping rotation 0.01. All right, and now if you press play to have a preview of the animation, you should see this. This basically just falls down. So the angle of the constraint is not correct because, as always, this is not visualized correctly. So this angle is not correct. I'm going to put this on 0. Instead, I'm going to try the positive upper value. I'm going to set this on 90. Play the animation. Yeah, this looks correct. You can see that the rigid body is following. It's looking correct. Okay, let's try to parent everything correctly. So there are two ways of parenting. You can parent with Control P, or there is also the child of constraints. We need to choose very carefully which objects are going to use the parent and instead which objects are going to use the child of constraint. Because from my test, I saw that there are some problems if you do this in a wrong way. So I'm going to start from the rigid body, which is this object here. It's going to be, let's go in the constraints panel, add object constraint. It's going to be a child of. Child of as a target, I'm going to choose manually write rig control. There we go. And choose this object here, rig control. So that every time we're going to need to move the car, we just need to move the rig control and everything is going to follow as well. Then I'm going to select the deform mesh and holding shift also the original hood mesh. That is this one here. And as a last element, maybe in wireframe mode, as the last element, I'm going to choose the rigid body, holding shift. There we go. So it's very important, the order, as always. I have selected the first, the deform mesh, second, the original mesh, and as the last object, the rigid body. In fact, the rigid body is a little bit yellow right now. And with this selected, instead of the constraint, I'm going to give a normal parenting. So just press Control P, set the parent to object. Alright, instead of the constraint, for the constraint, I want to give a child of constraint, and this is going to follow the rig control as well. Sometimes, as always, if you use a child of constraints, sometimes you might see your object moving in some other places for some reasons. So if this happens to you, just click on set inverse to fix this problem. And now, if you play the animation, everything should follow accordingly the rigid body. Look at this. And this is looking like working correctly. So to summarize, for this constraint, let's see the physics properties. The right angle was the upper X set on 90 degrees. Let's test all of this right now. Let's exit from the isolation, starting from frame 0. So press play to play the animation and select the sphere, press G. And yeah, look at this. This is colliding properly. This is creating this motion. So at this point, if you feel brave, if you want to invest more time and make some additional tests, you can even select this constraint, and in the physics properties, instead of using generic, you can switch to generic spring, which is going to give you additional options. Basically, the difference between the generic and the generic spring is that the generic is just opening or closing the door. Instead, the generic spring is also generating additional bounces, which is kind of interesting. But I'm not going to do it right now because I don't want to make this course overcomplicated. Now, there is one thing I want to do. The more some parts are done, and the more I'm gonna progressively put these parts inside the Maserati collection. So this hood, for example, the original mesh of the hood, I'm gonna move it inside the Maserati collection. The reason for this is that by doing this, I can turn off the collection of the parts. and just check what we have done until now. Let's test the dynamic paint, looking from the side, and I'm gonna press space, take the sphere, press G, you can see the deformation happening. Let's interrupt it, and look at that. We have a nice deformation happening, not only in the vertical axis, but also we have some space for the deformation with some walls if some frontal accident is gonna happen. This is working really nice. All right, and for now, don't worry about the fact that the door is gonna be always open like this. Just at the end, we're gonna create some lock constraints that are gonna keep the doors closed until the moment of the impact. But for now, it's not convenient. We are gonna just need to do this in just one click at the end when all the parts are gonna be already ready. So let's just move on. I'm gonna create now the left door.